Hello, Algebra students. We're ready for Section 8, and I know we are doing a flipped classroom, and I'm going to flip things out even more. I'm going to ask you to go to the second page of your notes. So really, go to the second page of your notes, and even go to the second part of the second page of your notes. We're going to do this whole note taking in reverse because I think it's going to make more sense to you if we start with the problems, what the problems are going to look like. The whole section here is called a difference of squares. Whoops, need the pen. Difference of squares. So if you'll notice, we have a difference problem, a subtraction problem. M is being squared and 64. What number squared is 64? 8. So it's a difference of squares. So to factor a difference of squares, we're still going to have two sets of parentheses just like we're used to. I'm hoping by now you can guess that they're going to have opposite signs because when we did the FOIL method, the middle term with the m's canceled out. So this is going to be m times m gives me m squared, and then 8, the square root of 64, times 8 gives me 64. So when you FOIL it out and check it, you get m squared minus 8m plus 8m minus 64, and they cancel out, and that gives us back what we started with. But our answer is m plus 8 times m minus 8. This is called a difference of squares. For number 4, if I just rearrange that problem, put b squared first, put it in standard form, minus 9. Do I know the square root of b? Sure I do. Do I know the square root of 9? Yes, I do. So it's going to be b plus 3 and b minus 3, and that's how you factor a difference of squares. Now, number 7, it has a check mark, which means you're supposed to check yourself, but it's a little bit tricky because we have y to the 4th. What times itself gives me y to the 4th? That's going to be y squared. So you're taking the square root of y to the 4th, which is y to the 4th to the 1/2, which equals y squared. So the square root of y to the 4th is y squared, and it's going to be plus and minus again because we want the middle terms to cancel out, and then the square root of 625 is 25. So it's y squared plus 25 and y squared minus 25. All right, I might let you check yourself on number 5, but let me come back over here and do number 2. I'm sorry, I was going across instead of going down. So I'll leave number 3 for a checkpoint also. Number 2 looks a little bit intimidating. What's the square root of 16y squared? It's going to be 4y. What is the square root of 16? 4. What's the square root of 81? 9. What's the square root of z squared? Z. So it's going to be 4y plus 49z and 4y minus 49z. So when you check yourself with the FOIL method, 4y times 4y is 16y squared. Then you're going to have 4 times 49z, which is going to give us, so that's going to give us 16 over 9yz. And this is going to give us a positive 16 over 9yz. And again, they're going to cancel each other out. And positive times negative is negative, and 4 times 4 is 16, and 9 times 9 is 81, and z times z is z squared. So I check myself, and I see that I am correct, that my final answer is the square roots, the sum of the square roots times the difference of the square roots. Now, number 8 does not look like the other problems. So if you refer back to our factoring, our step-by-step factoring sheet, whenever there's 4 terms, I'm going to try to regroup. So in the first half, I see an f squared that I can take out of. So that leaves me with f squared times f plus 2. And then a negative out of 64 and 28, I can take out a negative 64, which leaves me with f plus 2. And I'm sorry it's jumping around, I think it's that check mark. So now I'm going to factor out the f plus 2, and that leaves me with a difference of squares. So watch this, it's going to be f plus 2 times the square root of f squared plus the square root of 64 and the square root of f squared minus the square root of 64. And there's your full factored form of that big long polynomial. All right, number 6, I said I'd leave you number 3, so let me do number 6. I see a 5 and an x I can take out, so that leaves me with x squared minus 4. And now that's a difference of squares, so it's 5x times x plus 2 times x minus 2. I'm going to also leave number 9. So there's 3 problems there for you to try on your own and check your understanding. Please make note under these next 4 problems that there should be a 6 in front of this x to the third. And it says apply different techniques. In other words, don't forget everything you already know when it comes to factoring. So the first thing I need to do for number 1 is take out the greatest common factor. I've lost my pen. Hold on just a second. Okay, the greatest common factor is 9. So, and an x. So when I bring out the 9 and the x, I'm left with x to the 4th minus 4. Now, can I take the square root of x to the 4th? Sure I can. It's x squared, and the square root of 4 is 2. So now I have factored it all the way out. Again, that x squared makes me stop and look. If this had been another square number, I'd have to take care of another difference of squares. But since it's 2, I have factored it completely. Number 2, after you put the 6 there, we have to factor by regrouping. So what's our greatest common factor? A 6 and an x squared. So that leaves me with x plus 5 minus, I'm going to pull out a 24, which is going to leave me with x plus 5. So 6x squared, or let's rewrite that. If I write x plus 5, factor out the x plus 5, that leaves me with 6x squared minus 24. Now right there, I want to think that there's a difference of squares. Oh, you know what step I forgot? I forgot to take out my greatest common factor. Shame on me. So I'm going to take out the 6 right here because I see it. So maybe I should have put the x plus 5 at the end. It doesn't matter where you write it. Put it at the end. That'll make it easy to see where I'm getting my 6 from. So this is where I am. X plus 5 is in both. 6x squared minus 24. Factor out the 6. That leaves me with x squared minus 4, which is a difference of squares. So if you don't remember to take out the greatest common factor, it's going to make, as we talked about in class, your numbers bigger and bigger headache. So please don't do what I did. I'm actually in a hurry to finish this video, and you'll be in a hurry to finish your homework or your test, so please slow down and be careful. So there it is, all the way factored out, taking care of this difference of squares right here. All right, I'm going to leave 3 and 4 for you to check on your own. Let's look at this last statement. It says, in an equation, m squared minus 81 equals y, what is the value of m when y is 0? Oh, well, m squared minus 81, if y is 0, I can factor that. That's a difference of squares. And I'll have 2 roots. So it can be a -9 or a +9. So don't forget how to solve when y is 0. Now let's go back to the terminology on the first page. I'm going to leave these for you to do. Actually, I'm just going to let you omit number 3. So do 1, 2, and 4 on your own. I might even let this be a POD tomorrow. So if you want to go ahead and look at it, that one will be for good work. And let's talk about section 8, the new terms that we've talked about. The difference of squares. That's our lesson today. As we factor, we always first take out the greatest common factor, and you already saw me make that mistake live and on camera, so you know what that looks like. Then we're going to add a new second step. Look for a difference of squares. If they're perfect squares, like 9x squared minus 16, where you know the square root of 9, and you know the square root of x squared, and the square root of 16, then you can always factor it with the plus and the minus. Now don't forget to apply factoring patterns that you already know, looking for the product and the sum, or regrouping. So everything we know is still here in step 3 and beyond, but we're adding this new step in step 2. So our new vocabulary is the term difference of squares, which is always going to be a subtraction problem. That's what makes it difference. And they have perfect squares that are being subtracted. All right, the coefficient has to be a perfect square, and the exponents have to be even numbers, which you know, because if it's a x to the third, then it's not going to have a perfect square. All right, so when we're doing difference of squares, it's always going to be a plus and a minus, so it's the sum of the square roots of the two terms and the difference of the square roots of the two terms. So it's the sum of the square roots and the difference of the square roots. Okay? And on our next page, another a different box just to show you using A's and B's. Our first box had it with numbers. Now if you have a number squared minus another perfect square, this is the pattern that you will always follow. And I hope that it helped working it backwards so you could see why we call it a difference of squares. And you're going to be working number 5, where if I took the square root of 25, it's 5. And the square root of a squared is a, and the square root of 36 is 6, and the square root of b squared is b. And I'm going to let you finish that one. Have a super day.